comenzar, nuestra siguiente plática es Industria 4.0. Nos acompaña el señor Reese de Endress and Hauser, con una plática bastante interesante de mucho impacto en nuestra industria. Vamos a hablar de las tendencias de digitalización de las cosas, perdón, Internet de las cosas. Esta plática es un tanto interesante, va a ser pues en idioma inglés. Los va a acompañar el señor. Bueno, comenzamos.
It's either English or German, because I live in Germany, so it's, I don't think Germany's good. So, good morning, ladies and gentlemen. Do you want to close the door? No, there's a few people coming in still. Okay. So, good morning, ladies and gentlemen. The topic for today is all about digitalization, how that affects the mining environment. Okay. And it looks at the title, you look, smart sensors, smarter engineers. And there's a little bit of truth in that, okay? Because the world is becoming more complicated. Just quickly, a little bit about me. I'm British. You may recognize it's not an American accent. It's an English accent. I'm very old. I was born in 1965. I've got 30 years experience in the instrumentation market. And I have 4 children, which is also unusual for an English person. The oldest is 21, the youngest is 6. 3 girls and 1 boy. The poor boy. So, I used to work for GE, General Electric. I also worked for Miltronics, don't tell Endress and Hauser. I was 10 years with Miltronics, Canadian company. Level specialist. Also a specialist in things like belt scales, way feeders, all these kind of things. So I've got quite a broad experience in this. And there you can see some of the family pictures. And I'm a British guy living in Germany and working in Switzerland. The money's good in Switzerland, that's why. But I actually live 200 meters below this castle. It's not my castle, but it's a playground for my children. So you can see the British flag flying high on that one. And this is part of the Black Forest, okay? It's a beautiful part of Germany, but it's where Endress and Hauser started in Germany. And that's the office in Switzerland. So literally, from Germany to Switzerland, it takes me 15 minutes to cross the border. 15 minutes. I've never been stopped at the border. It's not like your border with USA. It's a little bit different. The only time I was stopped, the Swiss control guy said, he stopped me. He said, you haven't got your lights on and it's nearly light. That's all. I've been across the border with Iraqi people with big beards, anything like this, and never stopped me. But the lights, rules, very Swiss. Now, if you look at Endress and Hauser, it's quite a successful company. We're a family company. We have a turnover of about 2.5 billion. And this is the most important thing here. 6,000 patents. And patents basically mean research. Research into new products to fit and suit your processes. Okay? And that's what my job is. I'm an industry manager. My job is to look at the industry and to see what you need, and to give that information back to our development people to create smart sensors to fit your process. Okay? And that's where it started. It's actually in the village where I live, in Germany, Lörrach. And then it started in the 1960s, and that is one of the factories very close to us. People who come and visit say, I don't believe it, it's so clean, it's so organized. But that's typical German and Swiss people for you. Okay, always obey the rules. I've got children who don't let me cross the road. Even if there's nothing coming, as long as the light is red, you're not allowed to cross. That's typical German mentality. If you look at where we're located, we have 26 factories. So we're pretty close to you. The last factory was in Brazil, in Sao Paulo, for the Brazilian market. Now, mining is important to us, but it's not the only industry. A little bit like ECN. ECN do a little bit of business in the brewing industry, in the food industry, in the chemical industry, in oil and gas. But in this region, what's the biggest industry? It's mining, for sure. And that's my job. We make around about 10% of the turnover for Endress and Hauser comes from the mining industry. And last year that was about 160 million euros, actually nearly $200 million of instrumentation in mining. The other industries, not really interesting for me. If you look at my motto, my logo, my slogan, it's extracting more from less. Okay? And you can see the pictures that we have. You'll see these in the internet, endress.com. Okay? Now, Arturo is here. He said, this is not an advertisement for Endress and Hauser. He said this to all the vendors. So I'm not allowed to just talk about Endress and Hauser. So that's why we look at Vega, for example. They copied my picture. And they made him younger. It looks like the sun. I don't know where Siemens went, because Siemens did something completely different, and I'm not quite sure that works in our industry. I think they've taken the millennial factor, the look and feel with the beard and the funny rings, the earrings and stuff like that. That's the Siemens version. Now, if we look at what drives our industry, okay, from the top, we have an organization in your mining industry. Right at the top, of course, we have the bosses. We have the CEO or the CFO. Okay. We have any CEOs in the room? 1, 2. Any mining CEOs? Anybody who owns a mine here? Nobody owns a mine? It's a shame. Because I spend a lot of time talking to these guys. And one of the this presentation I actually gave to a whole bunch of CEOs, 200 of them, in Zurich and in Denver. Okay? But that's not important. What else do we have who's interested? We have process people, yeah? Process. Do we have any process engineers? Process engineers? No process engineers in the room. Okay, even more important than a process engineer is a metallurgist. Okay? Metallurgist. Do we have any metallurgists in the room? Yeah. Okay. Do we have any geologists in the room? Even stranger guys? No? The metallurgist for me is the most important guy. Because he is like a cook in the kitchen. He decides on the recipe. Okay? It's his recipe. The process manager just makes it work. Now we're moving down into the complicated area. Okay? How many maintenance guys have we got in the room? Mostly maintenance people. Okay? Maintenance. Okay. And we have a triangle. This is like a triangle. We put a triangle here. And at the bottom, we say their job is to persuade. These are bankers. Do we have any bankers in the room? Investment bankers? No investment bankers. Okay? Because these people, they provide money for your future. Obviously, they want some money back, so it's like that. Okay? So now we see a complicated situation. Digitalization is affecting all of this triangle. In this area, it's very simple. Simple. And as we go down, it becomes more complex, complicated. This is complex. And we'll show you why it's complex in a minute. These guys have embraced digitalization. They talk about the digital mine. They don't really know what it means. And I've spent many times now in the last 5 years talking to CEOs, trying to understand what they think it means and what it might mean, the potential, the possibilities. Okay? Now, and these are the drivers. The CEO wants the best operative costs. Okay? That's important. It needs to be profitable. Obviously, a big driver is safety. Safety means safe people. A lot of mining companies say, my mission is to get people who work in the mine home safely in the evening. That's a common thread, not just in Mexico, but everywhere in the world. Environmental compliance. That doesn't just mean keeping Greenpeace away. Okay, it has a much serious impact. We saw that in Brazil last year when one of the tailings dams burst. Okay, so safety and digitalization go hand in hand. Why? It's about data handling. Okay, so here we can see this is the complexity. We have volatile markets. The gold price has gone down. There's less big projects, but people now need to optimize to make less cost. Okay. We have increased energy prices. We have a shortage of natural resources. If we look at a typical gold mine, we're not digging big nuggets out the ground. It's a chemical process to extract the minerals. And often you only find 1 or 2 grams of gold per ton. That's common practice. This information all goes back to the CEO, of course. It comes from the geologist and the metallurgist. Climate change. And this is interesting. Multipolar world. I didn't really understand what that meant until Donald Trump became president of USA. Multipolar means really uncertain world. A little bit crazy, non-predictable. And German people like predictability. They like the world to be predictable. So the Germans and the Americans at the moment also have stress, not just the Mexicans. If we look at what drives the regulations in the mining industry, does anybody know this one? AMIRA. The AMIRA code. No? Basically, if you read this, you can take a copy of this presentation home. I'm not going to read everything, but basically what this is looking at is how you make the mine profitable. And they look at every single process in a mine, this organisation, and they describe how to optimise it. That's quite an important document, because they look at cost implications, they look at the implications of safety, and they look at the environment as well. And an important trend is this organisation understands that in a mine there is a lot caught up in the process, a lot of cost, and not just cost but of profit. So there's gold inside the processes. If you look at a gold mine, you have flotation, you have CIL, you have a lot of processes that contain gold. And if you can show how much gold is actually caught up in the process, you can report this back to the CEO, who can report it back to here and make more money. And that's the idea. Instrumentation needs to not just look at an instrument measurement value, it needs to do other things. That's what digitalisation is about. A sensor now has to become much more smart. It doesn't just do a measurement point, it looks at the condition around it. And that's the difference. And if we look, the data handling here, this is again the triangle. Consultants like to use triangles, don't you, Eduardo? You like triangles. Same triangle here is similar to here. And this is the area at the top and at the bottom. Endress and Hauser, Vega and Siemens can sit in multiple parts of this. Here is basically the things, the Internet of Things. So that's the sensors, that's the controllers, that's the valves, and all these kind of things that you see out here. But we also have people providing the data solutions, because each of this part of the organisation needs different data. The CEO needs to know how much money, the metallurgist needs to know if it's still working to his process, recommendation. The maintenance guy needs to know, are we keeping things working? Okay? And this is the stress area. So now you can see a few of the OZ Soft. Do we have any people from OZ here? Okay?
Yeah, the last presentation was here.
I actually like this American company, OZ Soft. They're here. I actually work with this one here. They're a Swiss company. But they do the same thing. They provide data based on your information from sensors. Okay? They provide dashboards, useful information. These are good companies to work with. Obviously, we know Rockwell here. Any people from Rockwell? Maybe? No, nobody from Rockwell. I made them a little bit bigger than the competition. That was all. So you can see we have a lot at the bottom here. We have not just trucks, everybody thinks about digitalization in mining, about driverless trucks and drones, but it's more than that. And we know that because you work with instrumentation, you work with valves. And that's the key part to control and keep control of a mine and the mining processes. Obviously, Endress and Hauser is one of the players, like Vega, like Siemens, like Yokogawa. These are all instrument vendors. There we go. I'm not allowed to advertise. But it's all about data control. Digitalization is about data. And why do we need data? Because at every part of the organization we have data capture and infrastructure and management and analytics and a visualization. But unfortunately, less than 1% of this data is used. So Rockwell provide you with a huge data visualization, but you use less than 1% of it. And this information, every time you see a fact, it comes from a mirror. That's their statistics. Okay? 1% of the data is used. That's terrible, really, because you pay a lot of money for a Rockwell control system. Even more money for an Emerson one. Now, if we look, this is the costs. This is data and costs. And if we look here in a little bit more detail, that's a lot of money. Dollar importance of data, 370 billion. So outside of this, you have human productivity. This is what you guys do in a digital world. How you operate, how you use the data. That's the smallest amount. We're moving up to equipment suppliers. So this is basically a supplier who provides just an instrument that measures. That's a small amount. But now we see the more importance. Health and safety is only 10% of the data. A large part is in your area. A large part is in maintenance, condition monitoring. That's significant. That's like a third of the value. The other part of it is a deeper understanding and optimization and automation here. So you can see that vendors like Endress and Hauser don't just need to focus on providing one measurement point. They need to think about this area in much more detail. And that's what I'm going to show you now. What you actually do in a digital world. I need to know the status of my device. How is it? Is it working properly? Is it still measuring properly? You need to look, can I configure my device? Is it simple to configure? If you're just configuring the measuring point, yes. But if you have a flow meter that can give you a condition of the chemical that's running through it, can you configure that? Is your maintenance people ready for that? A level device that doesn't just give you a level, but monitors the amount of dust in the environment, the amount of buildup in a silo. You can do that today, but how many people do that? Not many people. And that's why I say 1% of your data is used even in instrumentation, not just on the DCS side of it, but on the instrument side of it as well. And in addition as well, how do I manage my assets? Everything. You have maybe a 500 to 1,000. De Beers diamond company in one diamond mine has 70,000 IOs. 70,000 IOs. That's not just instrument but valves and a lot of other controls. Who gives the priority? Who says what's important when there's a red light flashing on the control room? What do you do about that red light? The technical manager of De Beers says I have 5,000 flashing lights a day. I don't know what the hell to do. So you need a system that gives you that. You need a maintenance system that gives you a help and advice on what's critical. And that's what the vendors have to do. They have to work with the instruments, the smart sensors, right up with the data providers like Rockwell, like OZSoft. And you have to have a combined package. And that's why ECN are in a very good position to give you this information, because they can combine all of these factors. Okay? So Endress and Hauser's part, or the vendor, the instrument vendor, has to think about making your life easy. Ultimately, a lot of them do that nowadays. Endress and Hauser actually do a little bit more in combining flow and level. They have a common look and feel, not just for programming, but also for the components. So you can take a component like a display out, of a level device, and you can put that in a flow device. A lot of kids these days all have iPhones, and touch screens are used. Everyone uses touch screens now on an iPhone or an Android. Nobody uses buttons anymore, not even me. So you have the option as a touch screen. These little things are quite important to the millennial engineer, the younger guy. Okay? It's a standard part of life. This is the network area. This is how we pass data from one point to another. And there's a lot of data medium. Okay? We have HART, for example. We have other digital mediums like Profibus. We have Rockwell use Ethernet IP. Now, data and data handling, as you can see here, comes in many ideas. Data storage, heartbeat technology. Heartbeat technology is a new theory from Endress and Hauser. It looks at condition monitoring. Every instrument that has this symbol can do a condition. Okay? It can measure the complexity of a chemical running through it. It looks at the deviation of that chemical if it changes, and it can organize a remix, a rebatch. Now, augmented reality is something else you may think about. If you want to just press the button over here, just click on the actual figure. See, that's it. That's the one. Okay. And this is a complex device. This is a liquid analyzer that measures metals in a liquid. And what you can actually do is use your iPhone or your tablet to do the training and setup. Very simple. It's an optical recognition, and this lady will tell you about it.
Hi, my name is Maximilian Bayo, and I will present you today a new innovative project of the conductor service, the augmented reality for process instruments. I'll show you now the different possible features of the augmented reality for our product portfolio. To access the augmented reality, we first have to download the app Aurasma. It's a free app for the iPhone and also Android phones. In the second step, we have to follow the Liquiline channel. It's a private channel which was programmed by Conductor Service. We open the app now and scan our instrument. The scan trigger is always a picture which is recognized by an artificial neuronal network, or ANN. This picture triggers the app to show us the augmented reality, which we already programmed in. So for example, we can link videos to the augmented reality and watch them full screen. With the augmented reality, we have also the possibility to give the user guidelines, for example, for a setup. So if we follow the guided steps from the instruction before, we come to the next screen. Here, for example, a spare part identification is possible. So we tap the components and get the material number of the different spare parts available. Also for different working steps, like a maintenance, a guided instruction is available.
You can look at the wiring as well. On a complex product like this, wiring is quite critical. So
another possibility of the augmented reality app is the evaluation of the device state. For example, the correct wiring, which you can see here. There are many possibilities for the augmented reality to help us in our daily working life. Also thinkable are the product structure explanations and also augmented reality enhanced work instructions. I hope you enjoyed this demonstration of the augmented reality.
That's just one app that we have. Endress and Hauser has about 10 different apps you can use to monitor different things. And here you can see this is our laboratory. This is our digital laboratory. And if you look very carefully, it's not just Endress and Hauser products. You'll see all the vendors' products, all the instruments, and all the DCS and PLC controllers. So if you have a question for complexity, you want to know how this instrument works on this system and how you connect it, you can ask us, or you can go on a training course. Very simple. There you can see the complexity of the digital world. So our instruments have to conform, or a instrument has to conform to Modbus, to Ethernet, to HART, to Profibus, all these different ways of looking at things. There you can see very simple mining process, and I'll talk more about the optimization of these processes tomorrow. But if we look at a simple thickener, Endress and Hauser will recommend the best instrument combination plus the advanced diagnostic setup to keep things running and clean and to monitor the condition that you can use. Okay? And this is not just something we've thrown together, this is something I've been working on for the last 10 years. So each process we can give you a recommended combination of instruments. Okay? And in combination with these guys we can provide a data system that suits you, a data recognition system that's important for maintenance, important for process, and important for the metallurgist, and also important for the CEO. And we can provide many different things. If you look here, this is the same program on a tablet. You can view your process on a tablet. You can walk around the plant, you can press the instrument, and it will give you a diagnostic of that instrument if you're within Bluetooth distance. Because many instruments now operate with Bluetooth or Wi-Fi. Okay? A flow meter will be able to be programmed remotely by Wi-Fi, either or directly with an Ethernet cable, without stopping the process. Okay? In the past, the process was stopped. Nowadays, you can do a verification of the instrument to see if it's working properly, directly with an Ethernet, your tablet, or via a server, sitting in the office or on the beach in Cancun. You can log in, you can put in the IP address of the instrument, and it brings up the diagnostics, it brings up the setup. You obviously have to put a password in, but that's your own procedures to do the passwords and things like that. Here you can see the diagnostics. The diagnostics are actually running to an industry standard, NE 107. You've probably never heard of that. But many of the vendors use these symbols. And behind each symbol usually pops up. So if you see here, maintenance, it will tell you exactly what the maintenance is doing, who's doing what and when. So it's all traceable. Endress and Hauser is not the only one that uses these symbols. Most of the major vendors use these, and that's a standardization in the industry. Now, if we look at what your life cycle of a plant looks like, okay? You buy an instrument. In the past, it used to last 100 years. Remember the old silo pilots, a level device, electromechanical, with a weight on it, it goes down, it touches the surface, it comes up, it measures the distance. These devices have been installed for maybe 50 years. Customer rings me up and says, your bloody device is not working. And I said, which one? He said, silo pilot. I said, silo pilot, how long has it been in? He said, 30 years. Come on, the world is changing. Flow meters that you bought 5 years ago were based on an old digital technology, like the Motorola telephone. Did everybody have a Motorola telephone? Yeah? What did you have?
Nokia.
You had a Nokia, the old Nokia phones, yeah? The Motorola technology, the Nokia technology. Who still has that phone, apart from you, Eduardo? Nobody. But that's how the world is changing in instruments, because it's changing so fast. I had a request the other day from a water plant in Monterey. They said, I have a flow meter and I want to be able to do a verification of that flow meter to check it's been working. And I said, well, you have to use this old Nokia-based technology. You plug it in. It doesn't have Wi-Fi, so you can't send the data from the flow meter to this device and then do a printout. You have to take it and plug it in somewhere else. Nowadays, you don't. You just, if you want to verify something, that the calibration is as good as when you bought it, it's automatic. You can log in again, do a Wi-Fi connection, print out directly from any Wi-Fi printer. Technology is changing quickly. So don't expect an instrument to last 100 years. It will last, but you don't get all the extra benefits. That's what you have to think about for the future. And that's all about life cycle. But our life cycle software, like a web-enabled system software from Endress and Hauser, it provides a library for this. It will recommend you can keep this flow meter for maybe 5 years, but maybe after 5 years you need to think about enhancing it if you want to optimize your complete process. Okay? and it gives you advice on this. Right? And that's WAM. And that's used in 150 mines globally. That's an asset management software. It doesn't just handle Endress and Hauser, it handles any instrument. Because most instruments use standard device driver technology, FDTs or DTMs. Okay, that's a digital device driver that sits inside an instrument that you can access using this software. Whether it's a Vega, whether it's a Krona, I don't care. Well, I do because Endress and Hauser pays my salary, usually. And that's what it's all about. Here you can see install base assistant, task scheduling, product status list, and you can this software, the WAM, you can tailor-make to your own plant. You can also now use your software from OSIS or QB to give you exactly what data you need as well from this system, because it gives you a lot of information. So the dashboards are important. For each stage of this, everybody needs a different look of what's important. And this is, again, a setup. You're not going to give me any more time. She's very tough. She's very German, isn't she? This is the last one, and you may like this one because basically, if you show my smartphone there, I've got an iPhone. So basically, as I said, you can walk around the plant, and you can press the button, and it actually shows you a list of what's in range. So you simply press, you put in the password for the instrument that you can see. I'm interested in a level device. The level device is actually 30 meters up here, and I'm not going to walk up the silo. So down at the bottom, you press the button. You press, each instrument has a password. You go in. It gives you the instrument, how it looks. Do you want to do a setup, or do you want to do a diagnostic? You can go into diagnostic. Obviously, it's in Spanish as well. You can do that. And you can look at, even in a level device, the echo curve. This is the strength of the signal. And this is the most important thing you're going to have. Because these signals can say, look, here, this is the measuring point, but here is a build-up. And when the threshold of the build-up, you can set the threshold here. If it builds up within a certain limit, you can automate a cleaning cycle. And that's not just for level devices, that's for pH sensors. That's for turbidity sensors. Any sensor that you have in the plant now, you can put a threshold on to give you a warning when it's dirty or needs replacing or needing cleaning. And that's important. The signal analysis is now much easier. It's on your iPhone. Okay? And here, the last one, you can do training. This is when I was in Namibia last year in Africa. We did 3,500 kilometers of the mines, mostly uranium mines. And we did a lot of training like this with a lot of equipment. But the last training you can actually do is software. Every instrument has a RFID, and every instrument has a QR code. So you can scan the instrument with this software, 3D QR, that's an app, a free app. And it will give you, you can look at the instrument, you scan the barcode, and it gives you an option to look at it and do your own training. So here you can see a 3D view. You can learn about the instrument, you can look at the importance of each component. So very simple, you can give your own staff an easy training based on the instrumentation. So the sales guy doesn't even have to carry the instrument anymore. You just have to have a barcode, QR code. So hopefully that's giving you an idea about digitalization, not just for Endress and Hauser, but the world in general. Okay? And as you can see, this is now, you can see smart sensors really do affect profitability. And the CEO, if he has a good smart sensor network and a good data handling system, then he can get better investment. And this is my job here. I actually sit here and I'm a consultant. I'm actually a consultant for the Denver Gold Forum. That's 600 gold mines. And that's the European Gold Forum. And I make a lot of these presentations to investment bankers and CEOs to teach them about digitalization. So hopefully that's been useful. Thank you for listening. Okay, finito.